Hello viewers, you're welcome to my YouTube channel. Mathematics Made Easy. So in today's video, we'll be solving this beautiful integral question. This is a definite integral, and then looking at this integral, it looks very easy. Okay, but in today's lesson, I'm not going to use the normal method. You understand what I'm saying now? So I'll be using Riemann sum and then limit definition to solve this beautiful problem. Yeah, that's what I'll be doing into this video. Alright guys, so if you are new to this channel, please don't forget to subscribe, like, comment, and also share. Okay guys, so let's dive into the solution. So the first thing I'm gonna do is to record the formula we'll be using to solve this beautiful problem. Alright, then recall that the integral from a to b of f of x dx, okay, this in form of your definite integral, so this will be equal to limit of n tends to infinity, then of sum of k from 0 to n of f of a plus k dx, then multiply by dx. Okay, yeah, so that will be the formula we're going to be using. And then recall that this change in x, okay, is equal to the difference between the limit then over n, that is b minus a over n. All right, so that is the change in x in the formula. Okay guys, now let's move on solving the problem. So we all know our a in the problem. A is 1, while b is what? B is 4. So definitely we can find change in x. Okay, so we could say change in x is equal to b minus a, that is 4 minus 1 over n, so which is equal to 3 over n. So that is change in x. All right, then we could also find our f of a plus k dx, that is f of a plus k dx. So this is going to be equal to, a is 1, so we have f of 1, okay, plus k dx, which is 3 over n. So this is equal to f of 1 plus 3k over n. That's beautiful. Now let's find the value of f of 1 plus 3k n. We could call this f of x. Okay, so we can say f of x is equal to s squared plus 2x minus 5. So if we do that, so definitely we're going to substitute anywhere we see x in this function. So we're going to substitute 1 plus 3k over n. So that's what it means. I hope we are getting it. All right, so instead of me writing x here, so I could write 1 plus 3k over n to the second power, then plus 2 into bracket 1 plus 3k over n, then a minus 5. Yeah, that's beautiful. The next thing you're gonna do is to simplify completely. So if you simplify completely, if you expand 1 plus 3k over n to the second power, so this is going to give us 1 plus 6k over n plus 9k to the second power over n to the second power. Then if you open the bracket right here also, so you have 2 plus 6k over n, then minus 5. So this will be equal to, if you collect like terms, so we're going to have, 1 plus 2, that's 3, 3 minus 5, that's going to give us negative 2. Then plus 6k over n plus 6k over n, that's going to give us 12k over n, then plus 9k squared over n squared. Yeah, that's cool. That's cool. So that is our f of 1 plus 3k over n. So guys, we can now rewrite the sum right here. So if we write a sum, so let's do that. Let's write a sum. If we write a sum, we're gonna have the following. Yep. So we're gonna have integral from 1 to 4 of x squared plus 2x minus 5 dx equals limit of n tends to infinity, right? Then of sum of k from 0 to n. So instead of writing f of a plus k changing x, so we're gonna write this guy right here. So we're gonna write negative 2 plus 12k over n plus 9k squared over n squared, then everything multiplied by your change in x, which is 3 over n. Yeah, that's cool. That's cool. That's cool. All right guys, now let's move on. So the next thing we're gonna do now is to evaluate the sum and then the limits. Okay, that's what we're going to do next. So but before that, let's open the bracket. Negative 2 multiplied by 3 over n, that's going to give us negative 6 over n. So we're going to have limit of n tends to infinity, then of sum of k from 0 to n, okay, of negative 6 over n, then 12k over n multiplied by 3 over n, that's going to give us plus 36k over n squared. Okay, then 9k squared over n squared multiplied by 3 over n, so that's going to give us 27k to the second power over n to the third power. Yeah, that's cool. Okay, so we can now find the sum one after the other. So this will be equal to limit of n tends to infinity, then of sum k from 0 to n of negative 6 over n, then let me put the bracket here, it's very important, then plus sum of k from 0 to n of 36k over n to the second power, then plus the last one, which is sum of k from 0 to n of 27k to the second power over n to the third power. Yeah, that's cool. Okay, now you evaluate the sum one after the other. Then you can see this is negative 6 over n is not k, so we can bring that out as a constant here. 36 over n squared, we can also bring that out as not having k, so that was a constant also. So we could bring 27 over n to the third power out, that was a constant. Okay, now let's do that. So we're gonna have limit of n tends to infinity, then you're gonna have negative 6 over n, sum of k from 0 to n, so of 1, okay, then plus 36 over n to the second power of k from 0 to n of k, then plus 27 over n to the third power of sum of k from 0 to n of k to the second power. All right, that's pretty cool. Okay guys, now let's move on. Yeah, this is very common. You must memorize them. All right, so you must memorize this. Sum of 1 from k to 0 to n, so that's gonna give us n, definitely, that. So this will be limit of n tends to infinity of negative 6 over n, so this is gonna give us n, then plus 36 over n to the second power, sum of k from 0 to n of k, so that's going to give us n into bracket n plus 1 over 2, and then plus 27 over n to the third power, sum of k squared from 0 to n, so that should give us n into bracket n plus 1 multiplied by 2n plus 1. Okay, so that's going to give us n into bracket n plus 1 multiplied by 2n plus 1, then everything over 6. So that's going to give us, okay, then you close the bracket. Yeah, that's cool. That's pretty cool. Okay guys, now let's if you open the bracket right here, and we cancel out n right here. Okay, so also n is gonna cancel n right here, and 2 into that's 1, 2 into 36, that's gonna give us 18. Okay, what about here? 3 in 6, that's 2, 3 in 27, that's 9, then n we cancel one n right here, so we're gonna have limit of n tends to infinity, then of negative 6, okay, plus 18 into n plus 1, then plus 9 over n to the second power into n plus 1, then multiply by 2n plus 1. Don't forget over 2 here, so I could bring the 2 here. Okay, so now if we open the bracket right here to simplify this thing completely for us to be able to find the limit, all right, so we have limit of n tends to infinity, then of negative 6, 18 multiplied by n, that's going to give us 18n, 18 multiplied by 1, that's going to give us 18, then 9 over 2. Okay, before that, let's expand this guy. So we have 9 over 2n squared, and into n multiplied by 2, and that's going to give us 2n squared, n multiplied by 1, that's going to give us n, 1 multiplied by 2n, that's going to give us 2n, and 1 multiplied by 1, that's going to give us 1. Yeah, that's beautiful. So we have limit of n tends to infinity of negative 6 plus 18n plus 18. If you open the bracket right here, 2n squared, we cancel out 2n squared, so we have plus 9 then plus, n we cancel n here, so you have 9 over 2n, and then here also n we cancel on n, so you have and 2 we cancel 2, so you have 9 over n, then plus 9 over 2n to the second power. All right, so if you take the limits as n tends to infinity, so this we can, this will go, this will go, this will go. So what we have now is -6 plus 18 plus 9. All right, so what is -6 plus 18 plus 9? So definitely that's gonna give us 21. So that's the answer, that beautiful integral. So sorry, using your Riemann sum and then limits definition. So if you like this kind of video, please don't forget to subscribe to my channel, like my video, comment, and also share. Thanks for watching. See you next time. Bye. I love you all. Audio Jungle.